start the recording now. So welcome to the Living Well with Sickle Cell Town Hall. We are excited here at the Children's Sickle Cell Foundation in Pittsburgh. We're excited to have people from all over Pennsylvania, Ohio, and we have some folks from Florida. We're really excited. So if you would not mind putting your name and where you're located in the chat box, and something fun that you are looking forward to doing post-COVID. Just to have a little fun with that. We're not going to do that out loud. We'll just do that in the chat box. So we are going to just say thank you all for joining. This topic is super, super important. We did a town hall in September about sickle cell disease and COVID and how to stay safe. And this is a follow-up to that. We're really excited to have these amazing speakers with us today who have given their time, to this effort. And we have a wonderful surprise at the end for anyone who is, especially those in the Pittsburgh area. We have a wonderful surprise, and I know in Pennsylvania, sickle cell is 1A, so the vaccines are available in priority. So we're excited to be able to share the information with you. And without further ado, I will read all of the bios. Our format for today is I'm going to read all the bios of our esteemed panel speakers, and then they're going to give their presentations in succession, so one after the other, starting with Dr. Laura DeCastro, and then Professor Ohene Frimpong, and Dr. Lori Crosby. And I have the pleasure of reading their bios to you, and I'm really excited. So thank you for being here with us this afternoon. So Dr. Laura M. DeCastro is an Associate Professor of Medicine and Clinical Chief of Benign Hematology at the Hematology Oncology Division at the University of Pittsburgh Medical Center. Before joining UPMC, she directed the Duke University Sickle Cell Center during her clinical career. She has provided acute and longitudinal care to patients with sickle cell disease and other benign blood disorders. As a clinician, she works on addressing and managing acute and chronic sickle cell disease complications, chronic pain, preventative medicine, and psychosocial support. She has been involved in more than 30 NIH, National Institutes of Health, and pharma-supported clinical research, and as a principal investigator or site co-principal investigator, including designing studies, managing the regulatory and data-related and research-related clinical activities, resulting in outstanding enrollment and rapid completions of studies. She is co-author of more than 45 manuscripts on sickle cell disease-related research, covering the areas of psychosocial issues, pulmonary hypertension, use of social media and mobile technology for health-related outcomes, drug development, and pregnancy outcomes in females with sickle cell disease. Wow, that's a lot. And she is one of the docs here in Pittsburgh, and we are so excited to have her here on this panel. Professor Kwaku Ohene Frimpong, MD. Born in Ghana, Dr. Frimpong has his secondary school of education in Pompey College, completing his advanced level studies in science in 1966. Toward the end of the secondary school, he was selected to attend Yale University through the competitive African Scholarship Program of American Universities. He received his Bachelor of Science degree in biology in 1970 and was awarded the William Mallory Award for the Best Scholar Athlete at Yale. Following undergraduate studies, he won admission to Yale School of Medicine. For his medical thesis, he conducted a research project in Ghana called Child Health in a Ghanaian Community. That project solidified his interest in pediatrics. After graduation in 1975, Ohene Frimpong trained in the pediatrics in the New York Hospital Weill Cornell Medical Center. From 1977 to 1980, he trained as a research fellow in the Pediatric Hematology Oncology at Children's Hospital Philadelphia, University of Pennsylvania. He developed his interest in clinical research and sickle cell disease during his training at CHOP. Following the Hematology Oncology Fellowship, he spent 6 years at Tulane University Medical Center, where he established the Southern Louisiana Sickle Cell Center. He established the Northern Louisiana Sickle Cell Center in Shreveport. While at Tulane, he provided technical advice to the Louisiana Health Department for the development of newborn screening for sickle cell disease. He returned to CHOP in 1986 in order to continue clinical research studies in sickle cell disease. At CHOP, he directed several research projects at the Comprehensive Sickle Cell Center that he led from 1990 to 2010, including 3 5-year cycles of the Comprehensive Sickle Cell Program for screening newborns for sickle cell disease in Africa. At the University of Pennsylvania, he rose through the academic ranks, attaining full professor in 1996. In 2004, he and other concerned people of Ghana established the Sickle Cell Foundation of Ghana. Ghana launched its national newborn screening program for sickle cell disease in November of 2010. Professor Henny Frimpong is serving as program coordinator. He is currently Emeritus Professor of Pediatrics in the University of Pennsylvania and Dr. Emeritus at the Comprehensive Sickle Cell Center at Children's Hospital of Philadelphia. He is actively involved in Ghana, where he serves as president of the Sickle Cell Foundation of Ghana since January 2017. He has, He has devoted most of his time to working with national and international collaborators to continue research and develop sickle cell disease programs in Ghana and other African countries. In 2010, he was honored by the President of Ghana with the Ghana National Award, Order of the Volta. In 2015, the Millennium Excellence Foundation of Ghana honored him with a Millennium Excellence Award in 2015 for medicine. In 2020, he was awarded the Assistant Secretary of Health Exceptional Service Medal for exceptional achievement to the cause of public health and medicine, the highest civilian award from the United States Public Health Service, recognizing him for his outstanding contributions on behalf of the millions of people worldwide suffering from sickle cell disease. Dr. Frimpong is the first civilian recipient of the ASH Exceptional Service Medal. Wow, that was a lot. And we're so happy to have him. I like to call him my godfather. He's like my sickle cell godfather because he is so powerful and he is so amazing and has just done so much for me in this journey. Dr. Lori Crosby is a professor in the Division of Behavioral Medicine and Clinical Psychology at Cincinnati Children's Hospital College of Medicine. Her research involves partnering individuals, families, community agencies to improve health. Recently, she has been working to understand the impact of COVID-19 on the African American community and increased participation of African Americans and Latinos in COVID vaccine clinical trials. So, wow, we have a wonderful, wonderful esteemed panel, and we are so excited that they are here, that they're spending their afternoon with us. And so I am going to turn this over to Dr. Laura DeCastro. If you have any questions that you would like to put into the chat box, please put them in. We have chat box watchers who will be collecting your questions. And once all the speakers are finished, we will go through and we will answer as many questions as we can. And if we don't get to your question during this time that we have today, we will make sure to send out the answers, to get those answers to the questions and send them out to you via email. So, Dr. DeCastro. You're still muted.
Okay. Can everybody see my PowerPoint?
No, we can't see it. We can't see it. We can hear you, but we can't see the PowerPoint.
Yeah. Hi, can everybody see my PowerPoint?
No, just go ahead and share it.
Yeah, is it shared?
No, it's not shared yet.
Oh, I'm sorry.
It's okay.
Telling me that it's shared. Let me just get out of here. I apologize. You know, we tried before and we think we're ready, but we're not.
That's okay. We're ready. We're good.
Let's see again. How about
There
now?
we go. Coming along.
Yes.
That's good.
Perfect. Okay. Thank you, Andrea, and the Children's Sickle Cell Foundation and the other sponsor to putting this town hall together. I'm hoping that over the next hour and a half, we, all the participants in this town hall, have the opportunity to discuss issues about COVID-19, our personal experience, issues, risk and benefit and vaccination, and that we all come out of this town hall with a better understanding of not only the infection, the vaccination, and our own position and responsibilities regarding these issues. I am going to start with sharing with you some of the experience based on patients or individuals living with sickle cell disease having COVID-19. So hopefully over the next 10 to 15 minutes, I'm going to discuss the issues that outline in here. The background is that there is a growing body of knowledge that in the United States and even worldwide, Black and Hispanic individuals have increased risks from getting infected by the COVID-19 virus. Although the exact reason for the disparity of Black and Hispanic having increased risk than uh, um, other races is not clear. Specifically, data has shown that persons living with sickle cell disease have higher risk of the population of of having the complication that are associated with suffering with the COVID infection. And we also, again, based on that, I would like to discuss two case reports of individuals that had sickle cell and they were diagnosed with COVID and their outcome to put as a background of the possible complication that can happen. This first one relate to a young female who presented with severe right chest pain. Uh, they the vital signs were significant for normal, no fevers, no normal heart rate, good oxygenation, but the chest X-ray and the chest CT show basal infiltrate. So the patient was thought to have pneumonia and was started treatment with antibiotics, amoxicillin and clobemide. It was in the beginning of the COVID pandemic. The person have a nose and throat swab for COVID-19 and it was negative. She was treated, discharged on oral medication, antibiotics, and then next day she presented with fever, worsening overall uh, well-being, and was noted to have the chest X-ray infiltrate, and this time this person was COVID positive. She was again continued treated with antibiotics, treated with oxygen, managed the overall sickle cell pain that increased in the midst of both the pneumonia and the COVID presentation, and went home in 3 days. Oops. Oops, for some reason, my slides are not changing. Oh, sorry. So then the second case, this is a male with S beta thalassemia on hydroxyurea. He presented for worsening pain that was associated with the avascular necrosis diagnosis, but then on day 5 of admission, developed a low-grade fever. The chest X-ray was fine, and they even looked into possibility of having a infection at the hip, and they aspirated the hip and was negative. He had persistent fever while on antibiotics, has a full workup for both viral and bacterial causes of infection. And he was noted that, and then 10, he developed a cough. His oxygen saturation decreased to 82, requiring oxygen support, and also have increased hemolysis with decrease on their hemoglobin, etc. At that time, a repeat chest X-ray showed the presence of multiple opacities in the lung, and he, because of his drop on hemoglobin, was treated with a transfusion and was tested for the first time post-COVID and was found to be COVID positive. Even during that admission, he developed chest pain, difficulty breathing. Remember that he came with hip pain, oxygen requirement, requiring exchange transfusion given the fact that he had ground glass opacities consistent with acute chest syndrome. The patient remained in the hospital, but after the treatment with antibiotics, the exchange transfusion, etc., he had better oxygenation, but still had fever. So he ended up being enrolled in one clinical trial for treatment of COVID, and then discharged home in a stable condition on day 16. Um, these two cases put in contact the fact that investigators from Wisconsin decided to start a registry to really understand how many cases of COVID-19 were associated with having sickle cell disease. And so Dr. Pane Pinto, Dr. Brandau, and Dr. Sin initiated this registry a little bit more than a year ago. And as you see, this registry not only covered information from the United States, but also from all over the world. And as per March 26, or just a week ago, the count of patients entering the registry was 751. So again, this is all patients with diagnosis of sickle cell disease that were entering this registry after having diagnosis of COVID-19. As you see with the age distribution, follow the age distribution of sickle cell disease, even though there is a significant number of young adults, individuals between 10 and 20 years old, and then a decline but also basically individuals from 0 to 70 years. As expected, most of them were African American, but there was a small number of Hispanic, and a smaller number of white and Asian. And basically, we're a 50-50 proportion of males and females, even though a slightly higher proportion of females. The other thing, again, based on the age, this is a relatively young population with the average age was 22, but with a standard deviation of 14 up and down. In regard with the genotype of the individuals that were entered on this register with sickle cell disease, as expected, 65%, most of them were of the most severe genotype, sickle SS disease or homozygous S, but there were 20% with SC, and again, a representation on the other type of sickle-related genotypes. This is a summary of the history of prior sickle cell related complication in the past, and as expected, in 60% of them reported that they have had pain episode at least in the first years at least one time. But there's 30%, so 1/3 that has history of acute chest syndrome, and some of them with priapism, around 20%. And again, sorry, these are 60% that had pain that required hospitalization, and 50% of patients that had pain but were treated in the emergency room and released at home. Also, as expected, in regard with home medication, a little bit half of the individuals entering this registry had been treated with hydroxyurea, but again, you can see a number of them treated even with the newly approved disease-modifying drugs such as crizanlizumab, which is called Adagvio, L-glutamine, which is also known as Endari, and Voxelotor, as well as patients on penicillin, given that there was a lot of young population. Regarding average of hospitalization, individuals in this register were hospitalized due to COVID-related symptoms for approximately 7 days, but there was a large group deviation. This figure here basically outlined medical history. In green is the one that have it, and in green is not having it. And again, you can see basically all the complications that we see in sickle cell disease, from splenic sequestration, which was the one that was mainly observed. And again, this is probably due to the age of the individuals that were entering this register, but everything from silent stroke to kidney disease to ovarian stroke to vasculopathy and albuminuria was reported. They noticed that approximately 86% of those entering the registry have a history of receiving chronic transfusion. And you can see here that the reason for the chronic transfusion were multiple, from splenic sequestration to stroke to pain, acute chest syndrome, etc. And that most of the patients entered on this database had had a transfusion at least within the 6 months before, so an average of 27 weeks. Regarding symptoms while being infected with COVID-19, most of the, a very small amount have only pain. Most of the patients have pain and pneumonia, and out of 751, there were 10 patients that had renal failure to the point to requiring dialysis, with half of them not recovering from dialysis and half of them either recovering or the information not known at the time of that information came to the registry. In regard with treatment, what you see here is that patients receive a lot of treatment. Some of them got plasma, remdesivir, and tocilizumab, which are a standard therapy in most of the centers for COVID-19 patients. Some of them received chloroquine, that even though hydrochloroquine was not approved for that, in some centers that happened. And a lot of them receive anticoagulation with heparin because of the non-complication of all COVID of being association with clotting disorders. Lastly, in other interventions, most of the patients had ED visit and went home, but 50% were hospitalized, and some of them require an intensive care unit admission. Half of those admitted required transfusion, and some of them even require being put on a ventilator. The average hospital length of stay, as I mentioned before, was around 7 days. And sadly, as the time of this report, they have reported the death of 19 patients of those involved in this study. As you see here, most of the patients were considered to have mild disease, and the criteria to mild, moderate, severe was defined in the registry, but half of the patients had, moderate and severe disease, which again may have resulted either in death or in further complication. I'm going to skip this table that basically compare those with deaths and those that did not pass, just kind of to show you that those that had death were older, required transfusion, may have a history of a stroke, and then have higher rate of hospitalization for pain. Dr. Caterina Miniti and a group of other investigators from New York, Boston, Chicago, etc., really published this early of this year, showing that looking into 4 centers, Detroit, New York, Chicago, and Boston, and the number of patients with COVID-19, they have 2/3 of them, 3/4 of them were hospitalized, so 75% and 10% death, which was similar to the study, to the registry, and that they felt that having pain, developing acute chest syndrome, history of pain and acute chest syndrome was associated with increased risk of death when if they had the COVID-19. And they also found increased risk of death on those patients that were not on hydroxyurea. I'm going to also skip this one. This is on those 66 patients that were, 70 patients that were involved in this collection. They basically highlight the type of treatment that they receive. Most of them receive antibiotic because the association with pneumonia. A lot of them got anticoagulation because of the association of COVID with clots. Again, most of them 60% receive a transfusion, require oxygen supplementation. As I mentioned before, some of them receive the COVID typical therapy, including steroids, biologicals, and again, some of them requiring intubation. This is, I tried to update this data, but this is our data from UPMC at that time, and this is early January. We have 18 patients that were part of our adult patient. This is all the adult data diagnosed with COVID. Now this number have gone up to 30. We have had 3 patients that have been diagnosed with COVID twice. We don't know if this is prolonged infection of new infections, and then our data is similar to the registry one, with the exception that we have almost half the same amount of patients with sickle, with SS, with the homozygous, than with the heterozygous, with the SC. And also that, again, because this data is mainly for adults, our average age was 37 years, but we saw patients that were very young. Out of those 18, 7 were younger than 27, and 5 were older than 50 years old. And this, based on our data too, we will say that half of the patients had what we call mild disease, but even within UPMC, we had patients that have moderate and severe disease. 1 patient required intubation, ICU admission, exchange transfusion, and prolonged hospitalization. We have not had any death of permanent complication that we know about at this time. I wanted to just bring this concept about, so now we know that a COVID reinfection can occur, and there's initially there was a controversial topic thinking, is this patient just have the same infection but shedding virus longer, or do they have the capacity to get reinfected? Now we know more that, especially with the occurrence of new mutation, the Brazilian one, the South African one, and the English one, the England one, that people that have been infected with COVID can be reinfected with other mutants. So just to finish, because I don't want to take more of my given time, which I already have, this is some of the key prevention things: using masks, continuing your treatment, continue your management of your disease, your pain management, your transfusion, your testing, and being evaluated early if there is a suspicion of COVID-19. And again, if once a person have COVID-19, we're very aggressive in managing all the presentation, managing their pain, considering therapy for transfusion and pain management that are sickle cell related and also COVID related, as well as enrolling patients in clinical trials. I'm going to finish here with giving you thank you for the attention, and with just the take points that this is prevalent. This pandemic is individual with sickle cell disease. The individual with sickle cell disease really needs to make effort of preventing the disease and being aggressively evaluated and treated, and that there again a higher disproportional number of cases in individuals with sickle cell, being of the African American or Black or Hispanic in regard with other races, and that has to be put in consideration when we consider what to do, especially vaccination to prevent sickle cell disease. Thank you.
Thank you, Dr. DeCastro. Now we're going to hear from Dr. Professor O'Henry-Philippon.
Thank you very much. I hope you can see this slide now. I'm going to be quite brief, first because I don't know that much about the vaccines, and also because the experience with vaccines are relatively short, but we are really, really fortunate that for a disease that has been so devastating to so many people around the world, that in a short period of time of just a year and a half, we actually have vaccines that can help prevent this disease. And we hope that these vaccines will eventually make most people who have been afraid to get out, be able to go out and share friends with families, and that we will save many more lives through this. So briefly, I want to talk about the vaccines that especially have been licensed in the United States. There are several more in development, some in other countries, and others that are coming. As we just heard from Dr. De Castro, sickle cell disease, we have always been afraid that those with the disease may have a especially difficult time with COVID-19. First, because lung problems are a major problem in sickle cell disease, and initially COVID-19 came in as an infection that really almost all the serious complications we thought were restricted to the lungs. Now we've learned a lot more that there are other portions of the human system that are also badly affected by this vaccine. Also, there's a tendency to develop blood clots in sickle cell disease. This is how we clog our blood circulation, leads to causing pain, it leads to causing damage to the lungs, and COVID-19 can do the same thing. In our body's attempt to fight COVID-19, there's a lot of inflammation that is caused by this virus in different tissues. And sickle cell disease is a chronic inflammation disease. COVID-19 by itself doesn't cause pain, but we have learned that people who have pain with sickle cell disease tend to get worse pain when they have COVID-19. So we were really afraid that this virus may be a major problem for people with sickle cell disease. And as we have heard, the outcomes have not been so great for many compared to others. But now we have something that can help us fight this virus. Well, we've all become very popular with this virus and what it looks like with this spikes that come out of the body of the virus that give it the name the crown, which is what corona means. It's a virus that seems to be in the form of a crown. Viruses are very simple biological things. You can't even call them living things per se, because they themselves cannot do much for themselves. They don't breathe, they don't feed, they don't even multiply. They multiply by using other cells or other beings to do the multiplication for them, but they can be quite dangerous. So this particular virus is called an RNA virus. The RNA is a type of genetic instructions. Most of us have heard about DNA as the genetic instructions that we inherit from parents that have all the instructions on how the whole body works, all the different chemicals the body has to make. The instructions are carried in our DNA. To take the information in the DNA, if you think of it as DNA stored like in a library, and to take the instructions from that library and go to make something, that instruction is transported from the DNA through another type of genetic information carrier called RNA. And this particular virus, what its genetic information is the RNA. And part of the RNA in this picture says spike protein gene carries the instructions for making those spikes that are sticking out of the virus body. So there's that genetic material that makes it. So making a vaccine against anything at all means that you're going to expose that particular germ, in this case, this virus or part of the virus, into our immune system. And then our immune system learns something about the virus through whatever was exposed to it from the virus. And anything that is foreign to our immune system, the body tries to make a way to fight it as a foreign object. And in this case, the spike protein, which we know is the part that sticks to human cells and begin to cause the genetic material to enter and cause all these problems, that if the body can identify the spike protein and make an antibody against it as a foreign object that needs to be destroyed, then that's the way the body would fight it. So all these vaccines are trying to expose our body to something about the virus, that if our body learns about it and can fight it, Then when the true virus comes in, the body says, I can recognize you. You look like something I have seen before. It makes an antibody to attack that something, which in this case could be the live virus. So that's how vaccines in general work, is that we take either a virus that has been weakened or a piece of bacteria or something, and then fool our immune system to learn about that thing. And then when the real virus or bacteria comes in, our immune system says, I've seen you before and I know how to kill you, and then it tries to kill it. So we now in the United States have two types of vaccines. The first two that were approved were RNA viruses or messenger RNA viruses. Those were the ones that came from Pfizer and Moderna. And then the recent one, the DNA viruses from Oxford AstraZeneca. In the newspapers, you've heard that there's a fourth one that may be approved soon in America, the Johnson & Johnson one. But I'll talk about these two just as two types of ways in which these vaccines have been made. The mRNA viruses are completely new. We've never had, vaccines are completely new. We never had vaccines made from mRNA again. So I'll just quickly describe what has been made. So the virus has this mRNA, genetic information inside, and scientists are able to take the virus's messenger RNA and copy it, and especially copy the part that has the instruction on how to make that spike protein. So to make the vaccine, they take that little bit of RNA, genetic instructions on how to make the spike, and they put it in an oil carrier. And the oil carrier is really a coating to protect these instructions. And that's what the virus is. They're tiny, tiny little particles that form this virus to begin with. And also the vaccine material just contains just a little piece of information. So the vaccine is injected in you. And what this little instruction we hope will do is that it will go inside your cells. Your body will see the instruction and learn how to use the instruction to make the spike protein of the virus. So this is just a little piece of instruction that is forming the vaccine. So this little vaccine carrying the mRNA enters the cell, and the cell sees it and say, you look like you are instructing us to do something. The cell translates the instructions and it begins to put together the spike protein. So here is the messenger RNA that came from the virus, and it's being read by something else in the body cells called ribosomes. They read the genetic instructions, and the instruction tell it exactly how to put together a spike protein. So this is not the real virus. This is just a piece of the virus that comes in. But after it's made, the body sees that this is not part of us. This is something strange that has come into our body. It begins the same process that it will do from the infection itself, from the virus itself coming in. It's going to detect it, learn about it, and find a way to fight it. And so once the spike protein has been made, it can come to the surface, of the cell. It begins to display itself. Our immune system has ways of spotting things that are very strange. It begins to learn about it and design a way to try to counteract it. So these little pieces of spike protein that now is foreign, so in this case, it's called an antigen. Antigen is something that it's a new thing that has come into the body as a new formation of something. So that's where the gene stands for. Now your body sees and says, we need to fight it. So they make an antibody, something that is against the body to be made. There are special cells we have that actually detect antigens. They're called antigen presenting cells. They detect these little pieces of the virus that was made by you, but not the real virus. And then they have some other cells that will see these cells that have detected the antigen. And then they help them to stimulate another group of cells that actually make the antibodies. So these helper cells detect that these antigen presenting cells are carrying something strange, and they instruct another set of cells to make the antibody to go and fight it. So these helper cells come and instruct another cell called B cell. These are types of cells that were there, like white blood cells called B cells. and they begin to make the antibody on their surface. If you see them sticking out here now, so the B cell has taken instructions from the helper T cell that learned something about this spike protein, and now it's instructed the B cell to make antibody. The antibody then can detect the cells that have the spike protein on it and can actually begin to attack it. So when the real virus comes in now with a spike protein sticking out like this, now the body has a way. So we have seen this before. We've seen some things that look like this spike protein before, and we made antibodies against it. So the antibody will now come, attach itself to the real virus, and begin to destroy it. And that's how vaccines work. Both the Pfizer and the Moderna vaccine are using messenger RNA that it has copied from the real virus as instructions on how to make the spike protein. And the body then sees the spike protein made by itself on the instructions from the factory, in this case, not from the virus itself, and it can make antibodies. So when the real virus comes, it says, we know you and we can kill you. Now, this is how the Pfizer and Moderna things work. I want to quickly go on to the third one. So the Zenica vaccine is a little different. It tries not to use the messenger RNA from the virus, but it takes the instructions on the messenger RNA from the virus, and it makes a DNA version of it. The reason why it's good to make a DNA version of it is because the DNA is more stable. It is more sturdy. It can last for a long time, and you don't have to be so careful on how you store it. So they take the DNA, and in order to protect it, they put it in a virus that has been made inert, meaning that it cannot make you sick. When it gets into this cell, it doesn't really make it cannot make copies of itself to make you sick. But it's a good carrier for the DNA that is a copy of the mRNA from the virus. Well, DNA, when it enters a cell, goes to a special place in the cell. Unlike the mRNA that can just float in the cell and start working, the DNA has to go into where the body keeps its DNA. It's like where it keeps its real instructions. And that's inside a part of the cell we call nucleus. So that's why you need a virus to take the DNA into the cell and then to be able to inject the DNA into the nucleus where all of our inherited DNA instructions are kept. But this type of DNA vaccine, when it goes in, it doesn't really become part of your DNA, but it has the ability inside the nucleus to now make its own messenger RNA. Just like the other vaccines already came as messenger RNA, this time, this one carrying the DNA into your nucleus now makes a messenger RNA that has the same instructions on how to make the spike protein. So now the instruction is inside your DNA and it can put out its own messenger instructions. So that messenger RNA instructions comes out just like the vaccine that was messenger RNA. This one is made by your own body to make the messenger RNA. It starts making spike protein. And in the same way that spike protein then is recognized by your immune system as foreign, it detects it, it starts to start the processes of how do we destroy anything that looks like this. This is a foreign agent. So it uses the same cells that we talked about, the antigen presenting cells, the helper cells, and they stimulate B cells to make antibody so that when they see the real virus come in, they know how to fight it. So these are the two types of vaccines that are available. The messenger RNA vaccines have never been used in humans. They're new. They've been experimenting it with in animals and in laboratories. But it's amazing how quickly they can be made. That's the real attractive thing about this virus, this vaccine, is that whereas it would take years and years to make normal vaccines, these vaccines that are almost pre-instructed on what to do can be made very, very fast. And that's why in less than a year and a half, that COVID-19 has been around. There are now vaccines that can actually fight it and keep people healthy. So because they are new, we don't know a lot about them in terms of long-term side effects. But in the short term, for months, the people have been tested with these viruses before they were approved. We understand the short-term effects and how safe they are in thousands of people, and that's why they have been approved to be made. They've been tested in thousands of people, including many people who are of African descent, both in America, in other parts of the world, have been tested. So they were not made only in white people and were not made in Black people. So there's no reason why Black people should be afraid of the vaccines, because they were also tested in people of different races, including our own people. The side effects so far are all known to be very mild. Some people have maybe a little stronger effect. The side effects actually tell us that the body is reacting to something foreign. Means that when the vaccine came in, it acted like a virus, except it's not a real virus, but our body saw something foreign and it started to attack it. That's why we get a little inflammation where it was injected. We get some chills, sometimes a little fever, which would be expected whenever a foreign infection like a real virus comes in, except this time it's not the real thing. Over the years, over the next year, 2 years, 3 years, we will learn a lot more about the long-term effects of these vaccines. Since the virus changes its colors so much, and all the changes that the virus goes through happen to change the genetic material. So one vaccine may work for a while for one type of the virus, and as the virus changes, it may make a new type that the vaccine may not be so strong at killing it, and therefore a new vaccine will have to be made. That's nothing strange. These viruses can change very fast, and the science must stay abreast with the changes so that we can make new vaccines. So the message that for people with sickle cell disease and everything we heard, my message is just simple. Please take the COVID vaccine. It is here to protect you, to save lives. And if you're lucky to have survived so far and not had the COVID-19 infection, please, you are classified as a high-risk candidate for the vaccine, so take advantage of it. Thank you very much.
Thank you, Dr. Frimpong. We're excited to hear your strong words and get all the science behind that. That was very good. Thank you. And also Dr. DeCastro, just the two of you just bang that out. That was great. Thank you so much. Appreciate it. Lori.
All right. Hello, everyone. Good afternoon. Thank you for being with us. Bear with me just to go to slideshow. My little thing is at the bottom, so I'm having to move some things around here so I can get to the right button. Okay, hopefully you can see that in slideshow now. Hopefully.
Sure can.
Great. All right. I'm going to talk to you for just a few minutes about some reasons that people are feeling kind of stressed about this whole vaccine issue, which Dr. Frimpong alluded to. And hopefully by the time that we leave today, you feel more empowered, have more information. We've already learned a ton about COVID itself and sickle cell disease, COVID vaccines. And now we're going to really talk about how to think about it, how to talk about it with others as you go about your daily lives. So I'm hoping you guys can be my vaccine ambassadors. So I do want to thank a couple of my colleagues who have contributed some ideas and slides to what I'm going to talk about today. I'm going to talk a little bit about why vaccine issue may be stressing people out and identify ways to discuss the vaccine with others that empower them. So why are we a little bit stressed when talking about this vaccine? So the first thing to remember is that we have received over the months a lot of contradictory and inconsistent information, both about COVID and about the vaccines. And that information has come, it's been consistently inconsistent. Okay, let's say over time. And so when you receive information in that way, it's very hard to sort out what's real and what's not. And so part of this is that our expectations were that this would be short and we would sort of know what was happening with this coronavirus, with COVID-19 very quickly, but we didn't. And so we were prepared for a sprint instead of a marathon. And so we weren't expecting to learn, to keep learning and to evolve. We thought we would sort of stop it in X and be done with it. And that didn't happen. The other thing to know is that, you know, we have been given information in a way to manipulate our emotions. And so the way that information was presented, it has been presented sometimes in ways that will evoke fear, anxiety, and anger in us. And so we have a lot of emotions around this whole vaccine issue because of that, because of the way that it's been presented. And then we've been with misinformation or disinformation, depending on how you want to talk about it, but information that just isn't true, such as there's live virus inside the vaccines, which Dr. Frimpong just told you that there was not. So the other thing that has happened is we've been so exposed to media because we've been home, because we've become a digital society, that we've just stopped listening because some of the information was contradictory and inconsistent. So we've stopped trusting listening to typical media sources and even health-related sources. And instead, we tend to rely on anecdotal evidence or evidence from our friends and families or certain people in our lives. We are over relying on that because we kept getting contradictory and inconsistent information. So this is adding to this sense of stress that we have. What I want to show you is some recent data on vaccine enthusiasm and vaccine confidence in different populations. And I hope I didn't freeze. Let me know if I did. Yeah, I did not. What we know is that about 61% of people are saying that they are enthusiastic to take the vaccine or have already gotten the vaccine overall. And this is up from the 20% or 30% in December. And this has really increased across Hispanic adults. However, in the African American community and the Black community, we still are at about 55%. So we're still lower than the national average with respect to our enthusiasm and confidence about the vaccine. Why? There's a number of reasons, and I think that's what people need to remember. If people have concerns or are stressed about this, it's not just one reason, it's lots of reasons. And we have to think about it on a continuum. Where are people? Some people are like, I'm gonna wait and see. Some people are like, I'm definitely not getting it. Some people are like, I'll get it if it's required. So there's a range of responses and thinking about this. And when we're talking to other people, we need to remember that and meet people where they are. So for those who said that they would definitely not get a vaccine, here are reasons why. And you can see the top reason was just that it's new. Dr. Frimpong talked about that a little bit, and we don't have a lot of information about the long-term side effects. Although I will say that, mRNA vaccine development has been going on for about 20 years. So even though the COVID vaccine is new and this is new, there is a lot of data that's been around for 20 years on this type of vaccine or type of technology. And so it's new, but it's not new. But you can see that 17%, that was the biggest barrier. Another belief was about it not being effective against COVID-19, but we really know the numbers are telling us, and I don't know if you all saw this week, Pfizer came out and said that their adolescent version of their vaccine is 100% effective. So for 12 to 15-year-olds, they actually had no cases in the vaccine group that had COVID, where they had over 1,000 teenagers in the placebo group get COVID. So, they're now moving forward with their vaccine for teenagers. So you can see some people felt like they didn't need it. Some people, again, had questions about what's in it. We're going to send them to Dr. Frimpong because he told us all about that. Some were concerned about side effects, which he again assured us that these side effects mean your immune system is working. Is a good thing, and they don't last very long. Some people just don't like getting vaccines in general, so now we're asking them to get another one. And then some were concerned about getting COVID-19, which we know is a myth. You cannot get COVID-19 from the vaccine. Sorry, I'm trying to move forward my slides. I don't wanna move. There we go. So what we know is that in the Black and Hispanic community, people are more likely to express concerns. So especially if they're not able to get vaccines from a trusted place. And then they're also reporting more difficulty accessing the vaccine, like traveling to vaccination sites. And you guys probably saw that article. I think it made the New York Times, where some people from outside of a Black or Hispanic neighborhood came into that neighborhood and took all the vaccine appointments. So there are some issues of equity around vaccine access. And so I think that Ms. Matthews, Andrea will tell you some wonderful things about access that you all will have opportunities for in your community at the end. So what we know about the vaccination rates is it's probably a little higher now, but at the time of these slides in February, there were about 4% of white Americans who had been vaccinated, and that was 2 times the number of Black and Hispanic who had been vaccinated. And yet the risk, you can see, is 3 to 4 times as many in terms of suffering from from COVID-19 infection. And so what we also know is that there are, sorry, this was not supposed to be in here, but that's okay. What we know is that people are needing to hear various information to express their concerns. And that's one of the things I want to get get across today, is that we really we need to think about what our key messages are and how we're giving people information about the vaccine. So today is a wonderful opportunity, for example, for you to come here, talk to some medical professionals who are working with vaccination and really get that information that you need to feel confident, or get the references and resources that you can go to afterwards. So what we really need with vaccinations is equity. And I just want to say that African Americans and Latino Americans in this country and Native Americans have good reason to be mistrustful, because there have been many medical abuses in our history. And we are not represented in clinical trials as much as others. However, for the vaccines, what we know is that there were good representative samples of African Americans, Latino Americans, and Native Americans in those samples. And so they made a concerted effort to make sure that they did that with these particular vaccine trials. As a vaccine ambassador, one of our main duties will be to provide information about access to the vaccine. And we want to do that because you all are trusted sources in the community. So when you're thinking about providing information, remember that some people may have transportation challenges or support challenges. And so we need to make sure that when we're providing information, we tell them about weekend appointments or evening appointments. If there are central websites and how to sign up and they're difficult to use, lend a hand. For some of our seniors in our community, we started a group text where they could text someone and say, hey, I need help signing up. And then someone else would help sign them up, because it was all electronic in the beginning. So think about that. And I think, again, Andrea will provide you with some information about that today. But you all should know your local resource. What is the website in your community that you can go to for vaccine information that you can direct others to? And it's possible you can link through it through the foundation. And so that would be a great opportunity. If you want to know a national site, sciencepossible.com gives you 4 sites, the CDC, the FDA, et cetera. And you can go to that one site, and all of their vaccine information you can access from that one site. So let's talk about communicating. What we know is that when we're talking to others about the vaccine, it's very important that we're transparent. We validate where they are. We acknowledge their concerns. We provide them with evidence-based and accurate information. And we make sure that we as a trusted source, or if they don't have a trusted source, that we hook them up with a trusted source so they can get that information and really understand it. And one of the things we have to remember is that if someone says no, it doesn't mean never. It just means not right now. So it's important that we stay on top of the facts and combat misinformation. We need to be prepared to answer questions. We need to talk about what we know and what we're still learning, and that's fine. Be transparent and open. Here are some common myths and facts that we need to be ready to address. So the vaccines were rushed and not safe. That's not true. They were conducted in a parallel process instead of a sequential process. That's the difference. There was money given for all phases of the vaccine development up front. That doesn't usually happen. And so that's why they were able to be developed so quickly. It was not any safety corners cut at all, but there was differences in the process. So for example, instead of sending samples once a week, samples were sent 2 or 3 times a week. Instead of having to answer questions or queries about the study at the end of the study, those were done in real time. It had to be sent back on the same day. So there were just a lot of things where the data was collected and analyzed in real time versus at the end. So you can just really quickly read through some of those facts and myths, and I'll make that available for you all afterwards. I don't want to take too much time, but I just wanted you all to be prepared to be able to address some of those common myths. So what are the key messages? What you need to know and understand is that vaccines are close to 100% effective at preventing hospitalization and death from COVID-19. That's all 3, as Dr. Frimpong mentioned. So that's the Pfizer, the Moderna, and the Johnson & Johnson, which have all been approved in the US. And then scientists have been working on that technology, as I talked about, for the last 20 years. More than 100,000 people from diverse backgrounds were in the vaccine trials. And I'm one of them. So just being honest and disclosing that and transparent. And the majority of doctors and healthcare professionals who have been offered the vaccine have taken it. There's no cost right now because it's under emergency use authorization. But when the vaccines become licensed, there will be a cost. So again, something to think about. And while the long-term effects of the vaccine are unknown, Dr. DeCastro kind of talked to you about some of the effects. And so the long-term effects of COVID, they look way worse than the long-term effects of the vaccine. So I think something to think about as you're doing this. And then I just want to end by playing a video where we had some local leaders talk about their thoughts about the vaccine and their confidence in the vaccine. So let me reshare real quick and just make sure that I hit the right.
I can see it.
Okay. I just want to make sure. Can you still see it?
Yep.
Okay. I just hope that you can hear it. Let me know.
Hi, I'm Michelle Hopkins. Let's face it, we have been in a
Can you guys hear that?
Yes.
Okay.
fight for our very lives with COVID-19. We've been social distancing, wearing a mask, sometimes 2, staying at home a lot, and we've been washing our hands for 20 seconds at a time. And now that the vaccine's out, medical professionals are encouraging us to get the shot in the arm that could save our lives. You might think it's simple. The vaccine comes out and you get it. But for many in the Black and brown community, it's not that simple.
But we're ready to take your calls, and we're ready to find out why is it so hard to get you to sign up for the COVID-19 vaccine.
Lincoln Ware, he's the longest running radio talk show host in the city, a trusted voice for 48 years on the air in Cincinnati. Lately, the talk on his show is all about the COVID-19 vaccine, and every day, Lincoln tells his listeners he's getting it. Today, Lincoln is walking the talk, rolling into a drive-through at UC Health.
Ready to get that vaccine? Get ready to get it.
And within about 6 minutes, Lincoln is rolling up his sleeve to get the COVID-19 vaccine.
Relax your whole shoulder all the way down to the side. Perfect.
And just like that, he's done, taking the lead so he can let his listeners know what it's like. Let's face it, at 70, Lincoln also knows that the vaccine is his best bet to keep the COVID away. Lincoln joins other prominent Cincinnati figures who are addressing vaccine hesitancy by speaking out about what they consider the best weapon to fight the deadly virus.
I am going to get the vaccine because I want to be safe. I have 2 children, I have a husband, and I have creative work to do. And I want to keep the community safe. And more importantly, I want to get my life back.
So yes, I will be taking the vaccine, and I encourage everyone to do so. I'm a firm believer that we are our brothers and sisters keeper. So we need each other to do your part. I need you to do your part as I do my part.
The statistics are daunting. Blacks and Latinos die at higher rates. When it comes to getting the vaccine, the numbers for Blacks and Latinos are extremely low so far, only about 5%. A few reasons: mistrust of the medical community and fear of the vaccine.
The vaccine is not the problem. The problem is COVID-19. It's not vaccine, it's COVID-19. If you don't deal with the vaccine, you might not be around because COVID-19 will take you out.
That's straight talk from well-known pastor Damon Lynch. He and First Lady Barbara Lynch say they're all in when it's their turn.
We are going to get the vaccine together and to show people that it's okay to do it. And just like we do with the flu shot.
I have been vaccinated, and the reason I got vaccinated is because I want to make sure that I'm keeping myself safe, definitely keeping my family safe, my patients, but also our community.
Dr. Emmanuel Chandler is a pediatrician with Cincinnati Children's.
I, along with many other medical experts across the country, especially other Black medical experts, feel that the vaccine is safe. It's been done developed in a very safe way, and we trust the science behind the vaccine.
That kind of trust is lacking for many in Black and brown communities. That's where messengers like Lincoln can make a difference.
I don't have any side effects. My arm is not sore or anything, no more than it would be for a flu shot. So I'm good to go, waiting on my second shot, and I hope more people will follow me. We got it done.
Well, Lincoln makes the point with humor. All know the message is deadly serious.
I'm just pleading with you, and please get your vaccine when it's your turn. Don't forget to mask up. Don't forget to wash your hands, and don't forget to practice social distancing.
So stay safe and keep up the fight against COVID-19 so we can get to 0 cases in our region and get back to some sense of normal. Remember, we are all in this together. For more information on the COVID-19 vaccine and where to sign up to get a vaccine.
I'm going to stop there, but there's some local information given after that that I think is important. So I'm hoping you all will have that local information from Andrea today. I just want to end with a few take-home points. It's our opportunity and responsibility to ensure equity in COVID-19 vaccination. Trust and transparency are important. And it's the only way we're going to overcome the stress that has been associated now with this vaccine. And evidence-based approaches to getting that equity, include transparent communication, providing access to vaccinations, and really that targeted outreach from trusted sources. So that is it for me, Andrea. I'm going to turn it back over to you.
Okay, well, thank you so much. We're going to go to Q&A in just a moment, but I wanted to take get everyone involved and take a quick poll. There are 2 questions in our poll, and I will, so wake up, let's see how we do. I would like to see everyone participate. So there is the 2 questions. What is your role in the sickle cell community? And what is your vaccine status? Okay, so we have 18 out of 29. We're going to give you about 10 more seconds to participate, and then we'll end the polling and show us where we are. Okay. 3, 2, 1. Okay, ending polling, showing the results there. And I will save these. Just give me a second. Okay. Thank you for waiting for me to do that. Okay. All right, so let's go to the Q&A. Ty, do you have something for us?
Yes, so we have quite a few questions for the doctors here to answer. I think we have about 11 of them that people have asked during each doctor's presentation. So some of them are directed to the specific doctors, but I think you guys can just go ahead and answer at will for any of the doctors. So I'm just gonna go down the list. The first one is, so which vaccine is better for people with sickle cell disease? The 2 vaccines mentioned require 2 shots, while Johnson & Johnson only requires 1 shot.
Andrea, you want me to handle that?
Yes, please.
Really, all the vaccines that have been tested and approved, any one of them is good for people. The reason we are getting so many vaccines coming together is because of the need, the dire need to get millions and millions of people around the world vaccinated. So we are lucky that many companies have taken the opportunity to produce vaccines that all, as they're coming down the line, are being approved by the FDA, and the CDC has given instructions. So any vaccine that either your county or your community has available will protect you, and you should get it. The general advice is that for those that require 2 injections, that you take the same brand of vaccine. That if you got the Pfizer vaccine, that the second dose shouldn't be Moderna, that it should be still Pfizer, because they were tested with each other to see how much your protection or your antibody level goes up. All of us remember that, children, when you get measles vaccine or you get some of the vaccine, you get it at a few weeks, then maybe 2 months later, you get the same vaccine again, and then maybe 8 months later, you get the same vaccine. That is just to prime your immune system to build itself up so that when you come into the real infection, it can fight it better. So the ones that are 1 vaccine, they're advantage only because you get a needle stick only once. They're no better in protecting you than those that require 2 injections to protect you. So whatever vaccine is available, please get it and get yourself protected, and not worry about which brand may be a little bit better in tests. Those really don't apply in the real world. Just get the vaccine you can have available.
Thank you. This next question is for Dr. Crosby. What are your recommendations to tell a patient that said, I do not want to get vaccinated because I do not know what is in the vaccine, but if everybody around me is vaccinated, then I will be safe and not get COVID?
So I think, thank you for that question. And I think the first part is to make sure that they have the information about what is in the vaccine, because I do think it's important for people to know that. And so I think there is information out there to help people know, depending on what your level, because I don't have an MD, so I don't understand things to the level that Dr. Frimpong and Dr. DeCastro do, but there's information out there even for someone like me who doesn't have that MD to understand what's in the vaccine. So I think, we need to definitely let people know. For the second question, what we have sort of said to people is it's kind of like wearing your seatbelt. It's like you get into a car and you put your seatbelt on because it's an extra layer of protection just in case. And so the vaccine is sort of an extra layer of protection just in case. So it's great that everyone around you is vaccinated, but we want you to do your part as well, and also put your seatbelt on or take that extra step of protection. So I don't know if that answers the question, Dr. DeCastro, feel free to add more.
Yeah, I agree with your answer. I really have nothing to add to that. Yeah.
Okay, we have, what's the difference between the natural immunity and the vaccine part 2? Is it true that if you had COVID-19 that you have to wait a period of time to get the vaccine? If so, why?
Okay, maybe I'll try to answer that because that has been my experience. I had COVID-19 in Ghana in August, September. And so when I came here in November, I've been waiting for vaccine, and vaccines became available. The natural immunity, of course, in order to have natural immunity, means you survived the virus to begin with. Unfortunately, many people succumb to the virus. So you're lucky if you can survive to get real natural immunity. Natural immunity is the way we come into contact with many viruses as children. Children have a lot of colds. Their body's getting used to viruses that themselves are not so dangerous, and your body builds immunity. So as you grow, the same viruses don't make you sick. But for a very dangerous virus, you cannot really count on a natural immunity to protect yourself, because look at how many people have died, more than 500,000 people in America. In the face of all the excellent medical care in this country, look at how many people have died. If you are lucky to survive the infection, you have built a natural immunity, and we are beginning to understand more of how long that immunity lasts. The current advice is that you should actually get the doses of the vaccine as recommended, and that's how it's been done. The issue about waiting for a little bit is because if you have very high antibodies still in your body, you tend to mount a stronger reaction to the vaccine. And sometimes the inflammation that comes from the stronger reaction can make you feel very sick. Not because you're actually sick with COVID, but it's just your immune system is overreacting to the second exposure. So the general advice is that you should wait for at least 3 months or maybe even 6 months before you take the vaccine. But the natural immunity alone hasn't proven itself, because it hasn't been looked at from that point of view to make everybody feel that, oh, if you've had COVID before, you shouldn't get a vaccine. No, I waited here. I'm supposed to be in Ghana 3 months ago. I'm here because I was waiting to get a vaccine before I would go, which I have. Now I feel comfortable going. There's some new information that suggests that maybe if you've had the infection, for the 2-dose vaccines, maybe 1 dose may be enough. There have been about 4 scientific papers published, and the director of the National Institute of Health a couple of weeks ago issued a statement saying that we're still learning about it, but it seems as if for those who have been infected, 1 dose of vaccine for the 2-dose vaccines may give you enough of a boost that you may not need another booster.
Thank you.
Mm-hmm.
Okay, we have, if a vaccine is free, why are some places asking persons to bring a copy of their health insurance?
Okay, what I know now is that if your county or wherever you live, let's suppose, for old people or people with underlying disease that are sort of a priority group, if you go in your priority group, you don't have to pay. But if, say, you want your child to be vaccinated, out of turn, if there's vaccine available, some people may be applying a charge. I know some of the pharmacies like CVS, if you are in the senior group, the high risk group, you don't have to pay. If you want your children to be tested, then they may say there's a charge, because basically it's not your turn yet, and you are just choosing to do so. There may be a charge, and I've seen something as much as $140 being charged when children do this. But the idea is that as the vaccine become more available, I think the federal government's role is that the vaccine will be free for everyone. So I was a little surprised that some of the pharmacies would actually charge if you get your vaccine out of turn, so to speak. But I think they take the insurance information, such as, for me, I'm a Medicare age person, and they wanted me to, when I was registering, to give that information, but they didn't ask me to pay anything. And I don't think they're charging Medicare for it either. I think maybe it's another data they're collecting to see how many people in that group they have actually covered.
Okay. If I may add, I have not heard requests for insurance for anybody. I do know that approximately 15 patients with sickle cell have been vaccinated, and I can answer time there was a question about secondary effect. What I do know is that here in the state of Pennsylvania, all sickle cell patients are now within the category 1A, so they should be able to get the vaccine. Some patients have approached us and have asked us for proof that they have sickle cell in case they're asked for. And in some websites that when the person go and register themselves, it says that they may be asked for a proof of that specific disease. That's for patients that to make sure that the appropriate patient population receive the vaccine. If any of you would like to have, a note saying they're confirming your disease, just to not go through the issue of having to show when you go, please let us know and we will get you that information.
Thank you. Okay, is there anything we can do to prepare for this vaccine, like drink extra water, get extra rest, things like that?
No, not really. I think when you, most places when you go, they may ask you some questions as to whether you've had any symptoms or being ill, if you have fever, coughing, anything like that. But if the answers are no, they'll give you a vaccine. You don't have to do anything special. You don't have to get yourself worked up so that you can receive the vaccine. The vaccine is supposed to do it. It's work for you. You don't have to work for the vaccine. All right.
Okay.
We have time for one more question.
Okay. Does the panel recommend getting vaccinated by any or all vaccines as soon as possible?
Any. In a lot of places, the person that is going to be vaccinated do not have a choice. It's the vaccine that the place have available. And like Dr. Frempont said before, there's not really any recommendation of one being better than other, than 2 doses being better than 1. The soonest, the better.
Okay. Well, I have a couple of announcements that are related to the vaccines. If you live in Allegheny County, thanks to our relationship with the Primary Care Health Services, with Dr. Jerome Gloucester, they are allowing us to manage the sickle cell signups for their 9 clinical sites around the city. And so if you want a vaccine, all you have to do is put in, and Ty, can you put this in the chat box, support@cscfkids.org. You can send an email to that, or you can call the office, and she'll put the office number in there, and you can get on a priority 1A list. They will have doses at every Primary Care Health Services location, and the one nearest to you, you can be on their list. Now, one of the cautions is because you're on a priority list, and when you sign up, they want you to show up. So please make sure that you let the community health worker know. We have 4 community health workers on the call, and when you call, you'll be connected with one of them. And when you get, or 5, and when you get a chance to sign up, you'll be given a priority sign up time, and then you just go. We are offering as well some transportation assistance and some support for you as well. So that's going to happen in Pittsburgh. Excuse me. I know that the video that they showed, that Lori showed, was in from Cincinnati, and so I just wanted to share my screen, and hopefully I'll get my hold on, get my screen to do what it's supposed to do so that you guys can see something from Pittsburgh. This was my little surprise for all of you guys. Can you see that?
Yes.
And turn on share sound, and away we go.
I got vaccinated.
I got vaccinated.
Got vaccinated.
Hi, I'm Andrea Matthews, Executive Director of the Brashear Association, and I got vaccinated today, and I wanted to make sure that everyone in our community stays safe. The reason I want to get vaccinated is to keep myself safe, my family safe. I want to see my family. Can't wait to travel again. And we need to do all that we can to keep ourselves safe, our families, and our community safe. Come out and get vaccinated.
So I just wanted to share that I got vaccinated and it wasn't bad at all. And we just have to do everything that we can to keep our families safe. Thank you for your time and thank you for reaching out. And if you have any other questions, remember any question that wasn't answered on the town hall, we will collect those and send them out to you via the email that you registered with. So any questions that you have, you can either put them in the chat box now or you can send them via email at support@cscfkids.org. Thank you again, Dr. Frempong, Dr. Crosby, Dr. DeCastro. We love you all. Thank you for spending this time with us. We really appreciate you and all that you do to help the sickle cell community stay safe and with our families. So thank you so much. You guys have a wonderful, wonderful holiday weekend.
Thank you very much. Bye-bye.
Bye-bye.
Thank you.
Thank you.
Thanks. Thank
Hello,
you.
doctor. Thank you.
Bye-bye, everybody.
Bye.
Bye.
Bye. Thanks.
Hi, Zamoria.
Oh, hi. How are you?
I'm fine. How are you?
I'm good.
Great. Nice to see you.
Tell Janet I said hi.
I certainly will.